And now let's see, go ahead and share. I want to share pie chart, and I want to share Chrome. All right, hang on just a second. Figure out why we can't share Chrome. Second, make sure we're up. There's Chrome. Okay, that'll get us started. All right, so today is Wednesday, the 10th of February. The next 3 lectures, I'm going to try to do the best I can. The issue is there's so much tightly interrelated material that it's hard to structure because everything you want to talk about would be much better if you had talked about something else related to it. Lists, treating strings as sort of kind of lists, and then using loops to work with lists. So the way we're going to do it is today we're going to work with lists, so we're going to get started with it. We'll cover a lot of it. Some of the things may be awkward because I'm not going to talk about loops because loops are next week's topic, and we'll do the best we can. Administratively, again, you in this section have until next Monday, the 15th, to do homework 1. But remember, homework 2 is coming out on Friday, and it's going to be due Monday, that 22nd of February. So Monday, the week after next. So you always will have extra time in this section because I want to be able to have the Monday lecture before the homework is due in case there's any total problems that are coming up with it. It's easier for me to deal with it in lecture before you're due. Please, if you can, go ahead and get it done early because as I've warned you, things are going to start stacking up pretty quickly. We're already moving in through the semester pretty good. This is already the 5th lecture. We've got the first exam coming up in about 3 weeks. So get the homework done. And again, a reminder, you can submit the homework multiple times, right? Get it about 90% done and submit it. And then when you finish it the rest of the way, you can do that. Only the last submittal will be graded. It'll overwrite the previous ones. You should be good to go. So homework 1 due next week. Homework 2 is going to come out this Friday. Be ready for it. Before I get into lists, I do have to correct something that for some bizarre reason I went off on a strange tangent on Monday. Integer, division, and assignment are indeed defined. I told you they were errors. They were not. This was actually something I learned Python with Python 2, and they were errors. This was fixed actually a couple of years ago. I should have remembered that. So remember last time on Monday we talked about, because computer scientists are lazy, guilty, I am one, that in addition to the assignment statement, you have the plus equals, which is the same as, y equals y plus whatever. You have minus equals, you have times equals, and you have divide equals. Now what I told you on Monday, which was an error, is that the integer division equals / equals was not defined. It was an error. And a percent equals was not defined. That was an error. Those are indeed valid. They have been for a few years now in Python. So a quick reminder of what they are. When we say y equals 5, y integer divide equals 2, well, let's pick 3. What this is going to do, let's copy that and paste here, because there's some stuff I don't necessarily want to run yet in the coding file. Now we can see that this changes y to 1. So this statement right here is the exact equivalent of y equals y integer division 3. And remember that integer division, if you do division, quotient, and remainder, integer division is just a quotient. 5 divided by 3 is 1 with a remainder of 2. Integer division, you throw away the remainder, and it's just the integer division. Similarly, let's set y back equal to 5. And now we have y modulo equals 3. And in this case, what's going to happen, remember, again, integer division, quotient, and remainder, the modulus operator, the percent sign is just the remainder. So 5 divided by 3 is 1 with a remainder of 2. The modulus is, the remainder is 2. So in this case, this should just show us that y is equal to 2. And indeed it is. So for some bizarre reason, it happens. I told you on Monday that these two symbols are invalid and are errors in Python. They are not. They are perfectly valid and you can use them. So wanted to cover that. I had posted that online as an announcement that, whoops, sorry, after I realized that, yeah, I messed up. I went back and fixed it, but I want to cover that explicitly in class for anyone who missed the assignment. Now, that being said, those are operators that you should understand. Let's move on to the topic of lists. Everything we've talked about in variables in Python so far, you can hold one value. A string is 0 or more characters. It can have a lot of characters. You can have a big honking string, but you can have one string. An integer has one integer. A float has one floating point number. A Boolean has either true or false. Okay, it's, yeah, one is what you get. But there's a lot of time in programming when you want to have something that holds more than one value. Okay, and fortunately, Python gives you something called lists. Now, what we've talked about before are just called scalar values, one thing at a time. We're going to get into lists, which are the first of what we call vector variables. Vector, if you remember from your physics class or from math or whatever, has more than one thing. Scalar has one. Vector has more than one. We're done with scalar types for now. We're going to move into things that can hold more than one. Now, what I'm going to use as an example is a grocery list. Okay, the lovely hand model in the video is my wife. This is how you would make out a grocery list in the olden days before you knew computer science. You know, my wife would take a piece of paper and a pencil and write out milk, eggs, apples. I don't remember everything that was on the list, but, you know, had to do the shopping this past week. So in the old days, she would just write out this list, or I would write it out. Trust me, you do not want to see my handwriting. My wife's is much better. She would write out the list, and then at the end, you know, you would see something like this. It can't be read anyway. Okay, now I was just going to show you what the list likes. It's a people thing. Okay, but really, folks, you know, we're wasting paper, we're wasting pencils, you're writing out a grocery list by hand. So, I mean, let's face it, anyone, you know, can take your iPhone. This is my wife's iPhone 11 Pro. Pull up the Notes app, and come on, it's supposed to be an embedded. There we go. And all she's doing is she's typing out the grocery list on the iPhone Notes app. And so at least we don't have to waste paper that way. But this is before you knew computer science. This is what you did. Now that you know computer science, you're learning. What we're going to do is get you to do this yourself. You're going to write your own app. Okay? That's just, I was trying to throw something in there to make this less boring than me talking nonstop for 75 minutes. So, you know, we did the list with a paper. We did the list with the Notes app on an iPhone, what have you. Okay. We're going to assume now that this is my grocery list from this weekend. Okay, milk, eggs, cereal, coffee, apples, strawberries, broccoli, cucumber, tomatoes, green onions, and half. Had to run to Wegmans and get all this stuff. Now, in the example I'm going to work with right now, everything is going to be a string. That does not have to be the case. By the end of this lecture, we will cover things where lists do not have strings. And in fact, you have lists with elements that are different types. They don't all have to be the same type. Spoiler alert, that's for the end of class. But for this example, I'm just going to use this list of strings just because it was a grocery list I had handy and it was the easiest thing to do. So let's go to PyCharm and start playing around with this. Let's move down from correcting the error from last time. Lists. My grocery list. And I put in the triple double quote because this is going to be a long item. I just want to have them all handy, which is why I did it this way. Okay. So I'm going to declare a list variable, which I'm going to call L. L is just going to be a list. Okay. I could use grocery list. I think in the slides I actually did use grocery list. It could be fine, but again, you know, I want to just type L. So how do I declare list L to be a list? The simplest way is this. This L equals, now that is a square bracket. That is not a parentheses. That is not a curly braces. That is a square bracket. That tells you that L is a list. Now here I've kept this window in PyCharm open so that you can explicitly see this window in the bottom right corner tells you what variables you have. Remember I said earlier on the symbol table, this has the values of the symbol table except for the addresses. It tells you what the variables are that are declared and what value they have. So this one, yeah, we had y from the earlier example. Y is the integer value 2. In this case, it tells me that L is a list and it is empty. It has no value. Now, what is the significance of this 0? Well, at any time there is a built-in function in Python, len. Anything that is a list, I can take length, len, of that. In this case, it's going to be list. Next Monday, it's going to be strings, but for now, len of L says, what is the length of list? How many elements are there in my list? 0. That is what this 0 over here in this window of PyCharm tells me. It tells me that L is defined as a list. It has 0 elements in it, and its total value is just empty square brackets. So that is the simplest way to define a list. Now, if I know all the values ahead of time, then I can preload the list in the declaration. Remember, we don't have to pre-declare in Python. I'm going to say grocery underscore list, because we use snake case, equals the list of milk, comma, now, eggs. I'm going to type this out for just a minute, and then I'm going to cereal, coffee, apples. This, here we go. What came after strawberries? Broccoli, cucumber, tomatoes, green onions, and half and half. This, by the way, there's an equal sign missing here. Broccoli, tomatoes, cucumbers, green onions, and half and half. Okay. So now I'll copy this down here so that it's a different variable. And so now you can see over here that this is a grocery list is a variable defined as a type of list, and it has 11 elements in it, and they are these various strings. And so, for example, if I say over here, length of grocery list, it tells me that it has 11 elements in it, which is good. Now, some things to notice about the list elements. The members of the list are written out. Now, in this case, remember, we are talking because they're strings. If they're integers or floats, it's different. But because they're strings, we have the element, the string in double or single quotes. In this case, I use double quotes. The list elements are separated by commas. And I need to undo what I just did. Okay, so this is an element. Then the comma tells Python that's a separation. This blank space is just something I typed to make it easier. You didn't need that blank space, but that's fine. The comma separates the elements. Milk is the first element, comma. The next element is eggs, comma. The next element is cereal, comma. The next element is coffee. If I wanted to have a list of numbers, then of course it's the same thing. I don't need the quotes like I do for strings. Those are just lists. Now you can see that num list is a list. It has 5 elements, and they are 0, 1, 2, 3, 4, and those are the integers. So that's how you declare an integer list, a list of strings, a list of integers. Each element is defined as a string, as an integer, as a whatever, and they're separated by commas. So when you're writing your program, you can define a list either of the two ways. You can define a list this way, where you preload the values into the list, or you can do what we did up above with L, where we said L is an empty list, and now we will load the values into L. So let's figure out how we do that. Adding a value to a list, there are 2 ways. You can append, which adds the value to the end, wherever that is, or you can insert, where it adds the value in a specific place in the list. You tell it where to add. Okay, so we have L. Remember that L is our empty list. It has no values. Let's append the first item to list. The syntax is L, our variable name, dot, that's a period, append. It's spelled append. PyCharm, if you're using it, is very helpful. It tells you how to spend it. And then you say, here is the value I want to append to L. I want to append the value milk to L. Okay, and now we look at L, and over here it has 1 item, and that is the value milk. Well, append and insert have the same when there was 0. Now let's append the next value, eggs. Okay. And you do have to spell append right, or you will get an error. I get lots of those. Now we can see that L has the value milk and eggs. It's a list of 2 items. The length of L is now 2. Okay, that makes sense. Now we're going to start playing around with the indices. Indices being the plural of index. The location in a list of what number element this is in a list is called the index. Okay, here's an example. Suppose I said, what is L, the value, sub 1? This is the item in L with index equal to 1. Now, you may think this is the first item in L, but wait a minute. It turns out it's eggs. Indices in lists, this is very common in computer science, always start counting at 0. If we say, what is L sub 0? In this case, it's milk. L is milk and eggs. The first item is always L sub 0. So when you say, where in the list is this item? Okay, you always start counting at 0. So let's go to a longer list, the one we already loaded up. Remember that grocery list is this thing with item, with a list of items. In it, let's say, what is grocery list sub 4? That is apples. Why? Milk is 0. We always start counting at 0. Eggs is 1. Cereals 2. Coffee's 3. And apples is 4. So the item at grocery list sub 4 is apples. Okay. So when you're talking about what the index of a value index is of an item in a list, you always have to start counting from the first one has index 0. Everything else goes from there. Because of that, here is a very, very common error you will experience in dealing with lists. I'm sorry, I don't mean to be nasty. I'm going to predict you're going to have this error many times this semester going forward. It happens to me all the time. Remember that with our grocery list, the length of grocery list is 11. It has 11 items in it. Great. What is the length? Or I'm sorry, what is grocery list sub 11? That is, what is the last element in grocery list? Oops, that's an error. Wait a minute. This thing has 11 items in it. I want to know what's the 11th item. There is no 11th item because we start counting at 0. The elements of the list are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if you count, that's 11 items. Okay. So the last element in the list, let's try this again. Last element in the list is always index equal to the length of the list minus 1. The last element in the list is always length of the list minus 1. Now, what we've been doing in these indices, I've just typed in the direct integer. I have typed in the literal. The literal is exactly this number. We could use other variables to explain what an index is. Okay, we can calculate it. Suppose I say length of grocery list -1. Okay, let's evaluate, let's have Python evaluate that expression for us. Half and half, the last item in the list. Right? Half and half is the last item in grocery list. What's happening here? Python is taking what's inside these square brackets and saying, okay, let's evaluate. What is the length of grocery list? The length of grocery list, we already know, we've asked it multiple times, that's 11. Says so right here, list of 11 elements. Okay, 11 minus 1 is 10. So this says, go get me the item at grocery list index 10, or sometimes you'll hear the term grocery list sub 10, subscript 10. Go get me the item at grocery list sub 10. The item at grocery list sub 10 is the last one in the list, and in this case, that's the string half and half. Life is good, it works. Something like this, grocery list sub length of grocery list, is always an error. Okay. Anytime I do something like this, grocery list sub or index length of grocery list, that is always an error. It's always an index out of range. Why? Because the last element is always the length minus 1. Because the length starts at 0 and goes up. And so the length is always one number higher than the last index. Okay? So what happens is, you know, as you work through programming, as you work through coding, you're not going to know ahead of time how many items you have in your list. You're going to be adding lists. You're going to be subtracting, so on. Okay, so I wrote my Python program and I constructed my list, right? And I called it L. L right now only has milk and eggs. Now I want to add something else to it because, you know, my daughter, the recent UMBC grad who is changing careers, she used to work for Google, now she's switching, you know, is currently living in the house and wants to get something else. So she said, you know, get some strawberries. So L.append strawberries. And that's a parentheses, not square brackets. Common mistake, it happens all the time. So debugging your program is a skill. Now I've added strawberries. Now my wife says we need bagels too. Add bagels. I don't want to add bagels at the end because I happen to know that in the store there's various aisles. I'd like my list to be roughly in the order I'm going to go up and down the aisles. So I want bagels to come between eggs and strawberries. So if I append bagels, bagels is now at the end of the list. I don't like that. Okay. So I'm going to get rid of that. Pretend you don't see this because I'm not going to explain it till later. I'm back to milk, eggs, and strawberries. If I want bagels to come in the list here between eggs and strawberries, I know that that is 0, that is 1, and so I want it to be 2. Strawberries is 2. L sub 2 is strawberries. Now, to insert in a specific place, I say L dot insert in location 2. Now, this is always an integer, comma, or something that evaluates to an integer, bagels. Now you can see my list, and I have indeed put bagels in between eggs and strawberries. When I appended it, it went at the end. Instead of appending it, I inserted it. I inserted it here. Why would you want to insert it instead of appending it? Possibly because you want to keep your values in alphabetical order. Possibly because you want to keep your values in numerical order. Possibly in this case because I'm going to use this program in a grocery store and I know what order I'm going to walk up and down the aisles and where I'm going to grab things off the shelf. Any reason you would want it in a specific order. Insert lets you keep it in a specific order, and append always puts it in the last one. Now, what happens if I don't know how many items there are in the list and I give an invalid number, a number way too high for the index? I want to do an insertion, okay? Milk, eggs, bagels, strawberries. I'm going to insert onions. I don't know how many elements there are in my list right now. I've lost track. I've done whatever. I mean, this happens. I'm going to say put it at index 10. Okay. Put onions at 10. Well, milk is 0. Eggs is 1. Bagels is 2. Strawberries is 3. There's not even a 4, 5, 6, 7, 8, or 9, let alone put this at 10. Python could give me an error. It could be harsh and say, look, pay more attention to what you're doing. You don't have an element of 10. But I'm just going to show you that it's nicer. Python, if you give it an index that's higher than the length, if you give an insert command and the index you use doesn't exist, it's higher than anything else on the list, it essentially becomes append. Python will insert the item as the last element in the list. It will not give you the error and go, look, pay better attention. The last element is 3. There's only 4. What do you mean 10? Python will go, all right, I'll let you slide. You know, I know this should have only been 4, but we'll accept it. So when you do an insertion, it puts it in a specific place. It moves everything else down. It will, if you give it an index in the insertion that's way higher than anything you have, Python will simply put it as the last element. It becomes functionally the equivalent of an append. Okay. What if I give it a wrong number? L dot insert minus 2. What have I not got? Grapes. No error. What the heck's going on? I mean, this is 0, this is 1, this is 2, this is 3, this is 4. What the heck is this minus 2? Well, let's look at L and then explain what happened. I make a note to myself to add these before I post it on the site. What did it do? What did Python do? It put grapes as 0, 1, 2, 3, 4, 5. Why is grapes here? Well, because if you use a negative number, a negative integer, as the index, Python starts counting from the end. the last, not the beginning, not the beginning and the last one. Okay. So right now, just so I don't lose it, I've captured this list that we created so far. What is L sub negative 1? Okay, let's find out. L sub negative 1. Onions, it's the last one. So if I say L sub 0, L index 0, that's the first item in the list, that's milk. If I say L sub 1, that's the second item in the list, not the first, that's eggs. But L sub minus 1, that's the last item in the list, which is onions. Why? Answer, this will not surprise you, is a combination of creativity and laziness. Remember what I said a minute ago. The last item in a list is always the length of the list minus 1. That's always the last item. The length of the list minus 1 is always the last one. Okay, L sub, length of L minus 1. That's always the last item in the list. So what can we do to save keystrokes? Drop the length of L. That's all it is. That's why in Python, minus 1 is the last element in the list. And if you count negative, you always get the, you start from the tail end, the last item in the list, and count backwards. Okay, here, remember, what's the length of L? 6. So length of L minus 1 is 5. So rather than force somebody to type length of L minus 1, why don't you make it so that they can type minus 1 and get the same item, get the 5th item? Counting backwards, what's the length of L minus 2? It's 4. So if I want to get the last item, or if I want to get the 4th item, 0, 1, 2, 3, 4. Length of L is 6, minus 2 is 4. Well, gosh, just counting backwards, minus 1, minus 2, minus 3, and so on. So as you do list programming, you will often find it convenient to start from the last item and work back toward the front, and you do that with negative values. So what have we covered so far? We've covered initializing a list with values like I did with grocery list. We've covered initializing an empty list like I did with L. And again, they're all strings for now. I showed with num list, we can do it with integers. It's fine. I've just done it with strings now in the examples. I've showed how to append an item. Append always puts it at the end of the list. I've shown you how to insert an item in a specific place. And I told you as long as that specific place is an integer, indices are always integers. As long as that index is an integer, Python will figure out where it goes. Okay. And if you give it a number that's too high, it just puts it at the end. Okay. What would happen if I said L or L dot insert negative 100, oh, I don't know, soup. What does L do? it puts it at the beginning, okay? Just like when I gave a positive index with onions up here, and I gave onions an index of 10, and 10 was too many, it just put it at the last. When I give it a negative index, and it's, way more than there are, -1, -2, -3, -4, -5, -6, sorry, I'm out. It doesn't circle, it doesn't loop, it doesn't spiral, doesn't do anything else. It says, okay, if you give it a negative number, that's too high. So we have covered how you insert or add values to a list. Now we want to talk about removing. And there are multiple ways to get rid of an item from a list. The first is remove, which gets rid of a value. Now, I did this up above, and I told you to ignore it. Now I'll get back to it. I want to remove the value eggs from list L. The way remove works is it gets rid of the item by value. It finds the first instance of this value and gets rid of it. Okay, doesn't matter what its index is, it finds it and gets rid of it. Now, it will find the first one. Everything so far, all the values in the list have appeared one time, but that's not a requirement. The same value can appear lots of times. So let's say L dot append eggs, L dot append or insert three eggs. And now let's see what L looks like. Soup, milk, bagels, eggs, grapes, strawberries, onions, and eggs again. Now let's go back and use our same expression. Let's remove eggs. Okay, and see what happens. We've still got this one here. This removes the first instance of the item, and first means with the lowest index. It starts from the beginning end and it gets rid of the first one that it finds. What if the item is not found? Okay, let's try that. L dot remove salt. There is no salt in my list, and I'm going to try to remove salt. Then your program will die a horrible screaming death because salt is not in there. We'll show you how to fix that in a couple of minutes. Okay, so if you give an item that is in the list, it will find the first one. The first one is closest to the beginning with the lowest index, and it will get rid of it. If you give it an item that is not there at all, you will get an error. I'll show you how to fix that. If you have an item that is in the list multiple times and you want to get rid of all of them, that's next Wednesday's lecture when we talk about loops. I said at the beginning, this is kind of awkward because, I know we've been shoveling a lot of stuff at you. You're kind of drinking from the fire hose, to use the expression. That it really gets intense today, next Monday, and next Wednesday because there's a lot of stuff that's all tied into each other. But we'll get you there. Don't worry. We'll get you there. Remove by value. If it's not there, it's an error. Your program will die if you don't do anything else. If it is there, it gets rid of only the first one. It will not get rid of multiples. If it's not there, it's an error. Okay, now, the next thing we can do is we can remove or get rid of an item by its index. And that uses the operator or the method. Okay, so L dot pop 3. L dot pop 3 gets rid of the item at index 3. Now, note, it does not get rid of the third item. Here is L right now. Soup is 0, milk is 1, bagels is 2, grapes is 3, strawberries is 4, onions is 5, eggs is 6. Pop of 3 gets rid of the item at index 3. 0, 1, 2, 3. This will remove grapes. It will not remove the third item, bagels, because bagels is at index 2. Confusing, I know, but you've got to remember you always start counting at 0. Why? Because everything is bits, and the lowest number you can represent is 0, so you start there. You start at 0, 1, 2, 3. So get L dot pop 3 will get rid of the item with index 3, which is grapes, as I said. And so now, if you look at it, you have soup, milk, bagels, strawberries, onions, and eggs. Now, I haven't really focused. I've got the slides that explain this, and we will talk about that when I get through the pie chart. But Python is automatically changing indices for you. You don't have holes in your list. Python automatically manages the list to fill in any holes or create more space. So up here, before I executed this statement, L3 was strawberry, L3 is now L3, what was popped was grapes. 0, 1, 2, 3. Grapes was 3, strawberry was 4. Now I got rid of grapes. So now soup, milk, bagel, strawberries. Strawberries is now 3. So we'll talk about it when we go back to the slides. But what's happening here is that Python is automatically managing all these indices for you. Python is not letting there be any holes, shoving things around, changing things. That's a nice feature of the language. It takes care of it for you. You don't have to worry about it. So the indices themselves aren't changing when you're doing this adding and subtracting. So when you want to get rid of an element in the list, by its value, you use the remove command. When you want to get rid of an item in the list, by its index, the thing at index 3, you get rid of it using pop. And there is one more nice feature to get rid of multiple entries at the same time. Remove and pop only let you get rid of one item at a time. Remember, remove only lets you remove the first instance of a value that it finds. Pop gets rid of the single value at index whatever. If you want to get rid of multiple entries from the list at the same time, that is the del command, del being short for delete. And that is L, the variable name, and now we're going to give the indices we want to get rid of. And so we'll talk more about this on Monday, lot 2 list, but for now we'll say 0 to 3. Let's look at L. Okay, 0 is soup, 1 is milk, 2 is bagels, 3 is strawberries, onions, and eggs. Now let's get rid of L 0 to 3 and see what we have left. What we have left is strawberries, onions, and eggs. Here's how del works. This gets rid of the list elements starting at the first number at 0 here and deletes everything up to, but not including the second number. So in other words, del L03 says start getting rid of list elements at element 0 and keep going until you get to element 3, but keep element 3. We are not deleting that. So what we've covered today are so far creating an empty list, creating a list with values, inserting, appending, removing, popping, and deleting. One more thing you need to know today, and we'll get to the rest next week, is the command in. In has the very nice property that it will return whether or not an item is in a list, whether it's an element of the list. And so here's why that's important. Remember our big long list, grocery list, has all these elements in it. If I try to say grocery list dot remove soup, it's an error because soup is not in that list. But what I can do is check and say, now I have to remember, the in syntax always gets me. Give me just a second, then I'll explain this. If soup in L dot remove soup. That is actually the syntax. How about that? I got it right in the first time. What this does is this will return, the in will return true if this element is in this list. It will return false otherwise. So I can take the if statements that I learned on Monday, the conditionals, I can take that conditional and use it. And I can say, if soup is actually in here, then I want to remove it. Since there's no else clause here, if soup is not in the list, I never try to execute the remove command. I don't need to. I don't need to remove it. It's not there to begin with. But my program doesn't die. I don't get an error. So in is a nice little Boolean function that lets us tell if something is in a list or not. And if it isn't in a list, then I can do something with it. I can print it out. I can remove it. I can multiply it by 35. I can do whatever it is I want to do it. This in function is very nice in that it lets me say I only have to do something if this condition is true. If this condition is false, remember our conditional programming logic for Monday, if this condition is false, skip this indented junk. Remember, spacing is important, white space is important. Skip this indented tab stuff. Don't do it. And because I don't do it, I don't encounter the error and my program doesn't fail. Okay, so in is a nice little Boolean feature, Boolean function that we have to rely on with lists to tell if something is actually in there or not. Now, in doesn't tell us what index it is. It doesn't tell us where it is. We'll have to go find that out, and that's okay. We'll talk Monday about how to do that. But it'll just tell us whether it's there or not. And again, in a case like this, what in does is stops our programming progression. It means we don't try to execute code that is guaranteed to fail. All right. Let's go back to the slides and provide some more detailed explanations of what happened with all of that mess. And in this case, I'm starting to use this habit I picked up a couple semesters ago. Anything in a yellow box is my note. Now, as I said, in this case, everything is going to be a string. Now, what happens in Python? We talked beginning of class, there's the symbol table that manages all the identifiers, and there are locations in memory that store the values. The symbol table tells you what location in memory everything is at. Well, when we have memory for a list variable, Python automatically makes sure that you have enough memory for all the locations, for all the values you're going to store. These scalar variables, these ints, these floats, these strings, Python really just sets up one location in memory. It stores it, it manages it. It takes care of them differently. Spoiler alert, the third part of the semester when we talk about mutability, we'll see why this is important. But for now, this is not on the first test. You don't have to worry about why this is relevant, but it just reserves one location in memory and it stores the value. For a list, Python automatically grabs as many locations in memory as it's going to need to store this stuff, and it manages it completely transparently to you, so you don't have to worry about it. When you say create a list, there's going to be enough memory to store the list. There's going to be all the management done behind the scenes. Every semester, no offense to math majors, I did earn a math degree, but I didn't bother to pick it up. Every semester people go, oh, these lists are just arrays then. They're just one-dimensional arrays. No, they're not. There are actually some differences, and we do at the very end of the semester get into why arrays are different. So don't believe that. They're not arrays. They're lists. Get into the mindset that a Python list is just a list of values, okay? It's sort of kind of like an array, but once we get too deep into it, it's going to cause you confusion, so don't think about that. It's trying to cut that off. So this is what memory is. When you say create my grocery list, Python goes out and it says, I got a space to hold milk, and I got a space to hold eggs, and I got a space to hold soup, and I got a space to hold onions, and I got a space to hold half and half, and as many as you want. And the symbol table says grocery list is a list, and it says go to memory and start there, and it'll deal with it. You don't have to worry about it. We talked about that. The square brackets mean to create an empty list. These are the square brackets. They're not the curly braces. They're not the parentheses. Or we can create a list with the values already inserted, which is what we did. Square brackets with the values. Again, these are all strings, but they could be any type. There is a term you hear in computer science all the time called method. It comes from object-oriented programming. Those things that we do to lists that we've talked about in this lecture are called methods. Now, the technical definition is that a method is something that operates on one object, one list in this case, and returns a value. So append operates on the list variable by adding something to it, and it returns the modified list. Remove takes the value out by value, not index, and returns the modified list. These are methods. A method is just a way of operating on the list so that it changes it in a way you want. Okay. So last time we learned operators. Operators are all those things like times, divide, and, not, plus, equals, etc. Methods are ways you can operate on a single object, a single list in this case, and change it and return the changed thing. Append is a method for adding an element to the end of the list. Remove gets that element by value out of the list. Insert puts it in a designated space. So we covered those already. Okay. Building the list, this is just an example. Append milk, append eggs, append cereal, all the way down to append green onions. That's fine. Each time we append or insert a new element into the list, Python manages the memory and assigns in the symbol table a location that says, this is grocery list sub 0, the first item. This is grocery list sub 1, the second item. This is grocery list sub 2, and so on. In the example in the slides, the last one is 9. Grocery list sub 9 was green onions. Okay, fine. Same thing I was doing in PyCharm, just slightly different numbers, but the illustration is the same. The first item in the list is sub 0. The second item in the list is sub 1, and so on. Okay, and that index is the subscript. You'll hear it say called sub a lot. Whichever index or subscript is fine. We don't care. But grocery list sub 2 in my case has this value. What's happening in memory when you add to the list, that again, the nice thing about Python is you don't have to see this. This is not a core part of the computer science programming, is that Python automatically manages that memory for you. When you append, Python goes and gets a new location in memory. It puts your new value there in that location. In this case, it added, I had sub 9 was the last one, green onions. It says index 10, sub 10, and it puts bagels there. It does that automatically. You don't have to see it. If you insert, in order to make room, Python will automatically renumber everything else. So when you say put bagels at index 1, well, 0 stays the same. That's still milk. Everything after bagels has to get pushed down. Python grabs a memory location. It says sub 1 is bagels. Eggs is now sub 2. Cereal is now sub 3. And all the way down to green onions is now sub 10. So Python automatically renumbers. Okay. And it automatically, when I say automatically pushes down, it renumbers the index. It renumbers the subscript. What's actually happening in memory, we don't care. It's actually depends on which version of Python you want. If you're really hardcore into that, we'll tell you how that works. But for our purpose, when we insert into the middle, Python shoves everything down a space and puts the new value right where you wanted it. If it appends, it's easy, it just puts it at the end. Okay, so all this memory management is happening behind the scenes automatically by Python. All you have to remember is the subscripts or the indices you want. Okay, same thing when you remove an item by its value. Python finds the item, it removes it, and it automatically pushes everything back up. It will not, this is what I meant when I said it will not leave a hole in the list. If milk is sub 0, eggs is sub 1, and cereal is sub 2, and you get rid of eggs, it will automatically push everything back up so there's no hole. There won't be a missing item sub 1. Python just fills in. Everything afterward gets renumbered. 2 gets renumbered 1, 3 gets renumbered 2, and the last item 10 gets renumbered 9. Python automatically, when you remove something, fills in the gaps, it shoves everything back up, it renumbers everything after what you got rid of so there are no holes. When you add something, it automatically renumbers to fill in, it automatically renumbers to make room. If you remove, it automatically renumbers to close the gap. Nice thing about lists is all this comes built in with Python. Okay, tools. The length function, we talked about it. Length, len parentheses of the list variable. Remember, the last index in the list is always the length minus 1. If you try to access list sub length, it's always an error because it's always one too many. Okay, so it's always equal to one more than the last index, or the last index is length minus 1. And because the last index is always length minus 1, we could get lazy and say the last index is always minus 1. And so we can always start at the end and count backwards toward the front. If in programming you care about the things at the end of the list, that's minus 1, minus 2, minus 3, and so on. Okay, so you can go backwards just like you can go forwards. Okay, this one we talked about length, list index of the length is always going to be an error, whereas this is never an error. It's just the last item in the list. Okay. If you want to find out a particular value is in a list, we talked about the reserved word in. Now, remember from the second lecture, which I guess was Monday 9 days ago, I talked about reserved words. I gave you that chart. We're gradually filling it in. In, IN, lowercase, is a reserved word. It's a useful function already defined that returns a Boolean, true or false. If this value is in this list, it returns true. If not, it returns false. And the value of that is you can avoid errors by not trying to remove things that aren't there. It has other uses as well, which we'll get to. But for now, in is very useful in determining whether something is a member of the list so that you don't try to delete something that isn't there, and thus you don't crash your program. There's lots more operations available. We'll get to them later in the semester, some of them on Monday. So the rest of the class will work on coding. This is when I did all my coding at the end of the class. I try to do it earlier now to illustrate things. Some questions. This is a fact, a frequently asked question list. Do all elements of the list have to be of the same type? No. Python can sort them out and manage them. I didn't give you an example of that. We'll do this on Monday. But yeah, you can have a list where the first element's a string, the second element's an integer, the third element's a float, and what have you. Right after I finish the slide, I'll give you an example of why that might be useful. Generally, you're going to make them the same type because if you're not careful, you'll get all kinds of errors. But if you know what you're doing, it can be done, and you can get good stuff out of it. And I'll give you some examples of why. When should I use a list? When you have a collection of data elements of the same type that logically go together. Items on the grocery list. When we get back to PyCharm, I'll give you an example of why it's on. When should you not use a list? When you have multiple data elements that really don't belong together. Okay. In general, you would not use a list to store everything about a student. We'll get into later in the semester what you would use. You're not going to use name, birth date, age, major, height, weight, all in a single list. You could. Syntactically, you could, but it's a very bad programming practice, so you probably don't want to do that unless you really have a specific problem. But you can do that. Wrapping this up, since I've got about 7 minutes left, this will just take 1 to 2 minutes. You can put different elements, different types. Student list equals the list of last name, which is a string, GPA, which is a float, grad year, which is an integer. You know, I would declare something like this. GPA equals 3.99, grad year equals 2022. And if I haven't made any typos, this is a perfectly valid declaration in Python where we have float, integer, and string all in the same list. But again, you're probably not going to do that. This is not the best way to solve anything. But it's syntactically valid in Python. You can do what you want. Oh, the other thing I was going to illustrate was suppose that I didn't want to use a list to do my groceries. Without a list. Well, that's going to be a problem because I'm going to have to define a string variable that says first item equals milk Second item equals eggs. Third item equals bagels. Now, how do I add another item to my list? What variable name do I use? I mean, how do I keep it together? This is another item in my list. I want, things that make sense that I look at and I say, okay, this is what I'm doing and why. How do I do this? So if I don't use a list, then this is going to be ridiculous, right? This very quickly will drive you insane. Will fail, and you'll go back to pencil and paper, which we didn't want you to do because it wasted paper, okay? So that was what we meant by when should I use a list? I have all those collections of data elements of the same type. They're all, in that case, strings that logically go together, items on my grocery list. Because doing that, writing this program that manages my grocery list without using a list, using separate scalar variables, is going to be a headache. I mean, you're just going to be in pain by the time you're done. You don't want to do that. Remember, the goal is, we know computer science now. We've taken 201. We can do this electronically, and we don't have to use the notes program, the notes app on iPhone. We can write our own program that says, input your first item, input your second item, input your third item. You build your list. And as you go through the grocery store and you put each item in your cart, remove this item, remove this item, remove this item, okay? You could write a very simple program to do that, and you now manage your own shopping list with your own interface and your own code, and you don't need notes, and you're not wasting paper. So that's the technique. That's why we would do this and when we would do this. And at that point, I'm going to stop now. I'm going to stop recording, but I'm still here. If anyone has any questions, I will be happy to answer them.
Hey,